In this video, we will be looking at properties of logarithms. So the first thing that we're going to look at is called the change of base formula. And the change of base formula is going to be very important to those of you that do not have a TI-84 calculator. Because if you only have a TI-83, as we mentioned earlier, you are only able to work in base 10 and base E in your logarithms. But there is a formula called the change of base formula that tells us that log base A of m equals log base B of m divided by log base B of A. I always remember it as log of big divided by log of base. Now, what that allows us to do is change from base A into any other base that we want to work with. So you have, say, log base 5 of 2. And we want to take that and put it into a different based logarithm. Well, the two most logical bases we might want to put it in, if we're trying to get a decimal approximation for that, would be either base 10 or base E. And we can do that by looking here and saying, all right, we're going to change this B, we're going to change into base B, we're going to make this 10. So this would be log of the big number, right, which is technically called the argument, divided by the log of the small, log of the base. So log 5. We could have also written that with a base of E and said that the natural log of 2 divided by the natural log of 5. So using this change of base formula, we've taken the base of A, and notice that the A is 5 here, and we've taken the logarithm of that in the bottom. Then the m, the thing we were taking the logarithm of, we just put that in the top. Now, as we showed in a previous video, I can hit the math button if I have a newer calculator, and I can go to log base, and I can find log base 5 of 2 by using that function. So I see that the log base 5 of 2 is 0.43067 blah 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 blah. But if I do not have a TI-84, if I'm using a TI-83 and I am limited to these two buttons, the example that I have here, let's just see if we do log. Now remember, since there's no base given, that's just base 10. Log base 10 of 2 divided by log base 10 of 5 gives us the exact same value. If I did the natural log of 2 divided by the natural log of 5, again, that gives me the exact same value. And the reason that is true is because of this change of base formula. Take a second, get open the second set of notes, Properties of Logs, section 4.3. Once you have that open, then continue with this video. In front of you now, you should have a sheet that says Properties of Logarithms. We are going to go over each one of these properties of logarithms and discuss how each property is similar or has a property of exponents that goes along with it. Remember that exponents and logarithms are inverses of each other. And so for every rule there is that has to do with exponents, there is a rule that is parallel to that in logarithms. Let's look at the big three: product rule, quotient rule, and power rule. The product rule says that log A of u times v equals log A plus log AU plus log AV. This actually goes along with the exponential rule, where when you multiply two things with a like base, you add the exponents. So in exponential mathematics, we've seen the relationship in the exponent between multiplication and addition. Same base multiplied becomes addition. Same base multiplied becomes addition. So this is how you can bring logarithms together or take logarithms apart. Let's look at a real quick example of this. Let's say I had log of 25 plus log of 4. So remember, this is base 10. This rule says that if I have log of 25 plus log of 4, I can turn that into log of 25 times 4, which would then be log of 100. And then 10 to what power gives us 100? 10 to the second power gives us 100. So log base 25 plus log base 4 equals 2. We can also use this type of thing to break logarithms apart. So if we had the natural log of x to the second yz, we could write that as the natural log of x squared plus the natural log of y plus the natural log of z. So the logarithm of a product becomes the sum of the individual logarithms. Log base a of u divided by v equals log base AU minus log base AV. This is the basic exponential version, right? This is the logarithmic version of the exponential rule, where a to the x, or let's use a to the u divided by a to the v equals a to the u minus v. So when we worked in exponential rules, we saw that if you have division, it becomes subtraction. Division becomes subtraction. This is really just a restatement of the other rule, in that the a to the u over a to the v never mind about that little piece. So we have this rule. Consider something that looks like this. Log base 5 of 75 minus log base 5 of 3. Using this rule, we see that that becomes log base 5 of 75 divided by 3, which would be log base 5 of 25, which is 2. So by utilizing this rule of logarithms, we are able to take what looks like an unsolvable problem and simplify it down to something that has a very simple answer. The next rule that we are going to look at, log base a of u to the n equals n times log base a u. In other words, if we have something to a power inside of our logarithm, we can swing that n down and make it into a coefficient. This is because, this along the same lines as when you take a power to a power, you multiply the exponents. So when you take a power to a power, it turns into multiplication. So when you've got a logarithm with a power in it, it turns into multiplication. So if we had logarithm base 5 x to the third, we can just swing that 3 down, and that's the same thing as 3 log base 5 of x. Please make sure to look at the common mistakes on the notes and notice how those things are similar to what we are talking about doing, but are not the same. A couple of other just important things. Remember that a to the 0 equals 1. Well, that means that for any base, the log of a1 will always equal 0. Log base a of a equals 1. And that is because, I should have put it first, a to the first power equals a. And lastly, log base a of a to the n, if I swing that n down, then I get n log base a. Well, this is just a 1, and so that's just n. That is all of the information for properties of logarithms. In the next video, I'm going to work some examples of expansion and condensation when it comes to logarithms and how to work with some of these properties. But as far as the formulas and the information needed, that's everything you've got.